Hey friends, so I've spent the last 5 years immersed in the sustainability industry, and one of the biggest questions that I get asked all the time by clients and family and friends as well is whether electric vehicles are really better and more sustainable than internal combustion engine cars. I wanted to put this debate to rest for good, so I've spent the last 2 weeks researching everything I could about electric vehicles and internal combustion engine vehicles as well to try and find out what the true impacts are across the entire supply chain. So in this video, we're going to be comparing some of the most common myths and misconceptions that people have about electric vehicles. We're then going to compare the total environmental impacts from EVs and ICEs and look at them side by side. And we're also going to go into some of the creative ways that people are addressing the key problems associated with the EV transition. So why is this important? Well, as you've probably noticed, EVs have recently taken the world by storm, and this is largely because they're recognized as one of the most important decarbonization technologies to help reduce emissions in the transport sector. Many developed countries are even going as far as banning internal combustion engine vehicles as soon as 2030. However, with all this talk about their environmental benefits, many people have started to point out that EVs aren't exactly the silver bullet that many people believe them to be. So how much truth is there to these criticisms? And are EVs really more sustainable than their petrol guzzling counterparts, or do they actually cause more harm than good? To answer these questions, let's dive into the science and look at the total impacts across the entire life cycle of both types of vehicles, looking at everything from raw materials extraction to driving to end of life and ultimately disposal. Specifically, we'll focus on three main factors. Firstly, we'll look at the supply chain impacts of the raw materials extraction and production of the vehicles. Second, we'll look at the environmental impact of running the vehicle. And thirdly, we'll do a side-by-side financial comparison so that we can understand the different key expenses at each stage of the vehicle's life cycle. So one of the biggest issues with EVs is around sourcing the raw materials for use in batteries. In particular, there's a lot of concern around human rights issues and local environmental impacts associated with the sourcing of materials used to make lithium-ion batteries. And while there are a range of different batteries available for use in electric vehicles, lithium-ion batteries are still the most commonly used. The key active components in lithium-ion batteries are lithium carbonate, nickel, manganese, and cobalt. Out of these components, we'll focus on lithium and cobalt for looking at supply chain issues. So in terms of lithium, Chile, Argentina, and Australia have the three largest reserves of lithium in the world. However, mining in Chile in particular has been associated with environmental damage. For example, water depletion, pollution of local waterways, and the destruction of sacred indigenous sites. So to put this into context, mining just 1 kilogram of lithium takes at least 400 liters of water. And with climate change expected to cause increasing droughts across the world, this issue of water depletion is only going to become more problematic over time. And in terms of cobalt, the majority of the world's cobalt supply comes from the Democratic Republic of Congo. Being such a poor country with such a heavy reliance on mining productivity to meet the country's basic needs, many of the mines, particularly the small artisanal mines, have reported instances of human rights violations such as child labor and dangerous working conditions. These supply chain issues are critical issues that will need to be managed effectively if electric vehicles are going to be sustainable in the long term, particularly given that the demand for lithium alone is expected to quadruple by 2030. These are the things that we need to get on top of now. So what can we do to address these problems? Well, there's a couple of different ways we can approach it. Number one is that we can repurpose and recycle the materials that go into making batteries, which would avoid the need to mine the raw materials in the first place. Number two is that we can look for alternative battery types that don't require mining of these raw materials at all. For instance, like what Tesla is doing by rolling out the new LFP batteries, which don't involve the use of cobalt or nickel at all. However, a major consideration with this is it could just be shifting the environmental problem from this resource to another. Number three is we can try to address the root causes of these supply chain issues in the country itself. This can be achieved by implementing things like clear labor standards at mine sites, monitoring and management plans, as well as sustainable sourcing strategies for companies that need to make use of those critical minerals. However, these solutions can be complex and costly to implement properly, and sometimes having organizations on site can lead to other issues in their own right. And number four is that we can manage the demand side of this equation by shifting towards a less car-centric economic model and prioritizing alternative means of transport such as trains, buses, and bike riding. But again, because this is a systemic solution that will take time and resources to implement, and because the EV transition is already well and truly happening, it's imperative that an economy-wide solution such as this one is used to complement the technological solutions used to decarbonize electric vehicles. So if we zoom in on battery recycling, how much of a difference does recycling and repurposing EV batteries have on the overall life cycle impact of the vehicle? Well, if we first consider that most EV batteries will last for about 10 to 20 years, and by recycling them, you're probably extending the lifespan by around 5 to 10 years, you can significantly reduce the amount of materials that are required to build that car. But recycling uses energy too. So how green is the recycling process for batteries? Well, I came across this interesting study that modeled the life cycle impacts of EVs with and without recycling to understand whether going through the recycling process has an overall net environmental benefit or not. They looked at the impacts in terms of emissions, air pollution, raw materials scarcity, and human toxicity. And when battery recycling was used, this led to an environmental impact that was between 8 to 25% better across all of these impact categories. Looking ahead, recent reports estimate that around 6% of global cobalt supply and around 15% of global lithium supply could be met by recycled materials by 2030. So this means that even with recycling, the majority of these materials is going to have to come from raw materials mining. Okay, so how do the supply chains of internal combustion engine vehicles compare? Well, it turns out that conventional petrol or gasoline cars are not without supply chain issues of their own. However, excluding batteries, the materials needed to make the external of the vehicle, the internal, and the engines are largely the same in terms of their environmental impact. Producing cars and engines and interiors requires the extraction of crude oil, which is an incredibly energy-intensive process. However, when we look at the numbers side by side, they're pretty much on par. So again, the main way to ensure the sustainability of these vehicle types is to buy secondhand when quality vehicles are available, as well as keeping cars well maintained and running smoothly and efficiently. Okay, so we've looked at all of the materials, the productions, and the supply chain. So how about the actual environmental impact from the use of the vehicle? So how long does it take for the life cycle emissions of an internal combustion engine to catch up to that of an EV? Results from a recent Australian Energy Council report showed that if powered by renewable electricity, it would take less than 1 year or around 10,000 kilometers for the emissions from an ICE to outweigh that of an EV. And that's just looking at greenhouse gas emissions. If we also factor in things like tailpipe emissions, so that's the stuff that causes smog, as well as things like noise pollution as well, EVs win by a long shot. But what if the electricity used to power EVs comes from a grid that's powered by fossil fuels? Well, this is actually the case in Australia, where some of our electricity in the grid still comes from fossil fuel sources such as coal. But even with our current energy mix, EVs still generate less emissions per kilometre driven than their ICE counterparts, and this is only going to decline further over time. Alright, so we've looked at these side-by-side environmental impacts. Now let's take a closer look at the financial cost breakdown between EVs and ICEs. Now the first cost that we should look at is the upfront cost. Now the upfront cost of an electric vehicle is still somewhat more than an internal combustion engine vehicle, and this is partially because the technology is still slightly less mature, as well as the fact that many EV companies are still sort of targeting that luxury car market. This is slowly changing, especially with many car companies moving to 100% new car sales being electric vehicles. By 2030, this price is only likely to come down further. And in terms of running costs, EVs are a lot cheaper. This is because charging EVs is an order of magnitude less expensive than petrol. In terms of the driving range as well, there is a common misconception, or I guess just outdated idea, that EVs have a much lower driving range than petrol cars. Now, in the last few years, this has become less and less of an issue, and now the average electric vehicle lasts for about 480 kilometers in a standard trip. So unless you're going on a really long road trip and you're going to need to charge very regularly at regional towns, this sort of distance should be reasonable for most types of trips. And there are still options as well for plug-in hybrid electric vehicles, which still have the benefits of being able to use electricity for charging in short distances, like when city driving, and offer you the option to switch to petrol for those longer road trips where you might not have access to refueling stations. Maintenance for EVs is also much lower, and most EV manufacturers will guarantee at least 8 years of battery life. When an EV driver would break even on their purchase would depend on a couple of things, so how much you drive on any given year, as well as any government incentive, as well as the price premium that you pay up front. So in terms of the main factors to consider when comparing internal combustion engines with electric vehicles, we've looked at materials, environmental impact, and cost. So in terms of material and production, the main issue with electric vehicles was the supply chain issues associated with mining of the rare metals and minerals used in batteries. These issues can be mitigated through things like sustainable sourcing strategies, alternative technologies, and recycling. However, there are still issues that need to be resolved by the industry industry as a priority if EVs are to be truly sustainable. In terms of the impacts from running the vehicle, EVs were the clear winner here, even when we consider the impacts from using non-renewable energy sources in the grid. In terms of cost, EVs still had a higher upfront cost, but this paid itself off over time. So while EVs do come out on top for environmental performance, there is still a really crucial need for us to change the way that we get around in order to make the best possible use of our precious and finite natural resources. While EVs are a solution, they are not the solution. Better urban design, vehicle sharing, and public transport systems are still critical elements of decarbonizing the transport system and preventing the worst impacts from climate change. And if you want to learn more about how you can contribute sustainably to the clean energy transition, check out this video here and we go into detail about how you can use your assets to make money. Otherwise, let me know what you think in the comments down below, and